You are welcome to GMAETS 41's YouTube channel. In our live stream class today, I am going to be giving attention to part 3 of Physics 102 exam focus revision. Yeah, this particular last part of the revision class was meant to take place by 5 p.m. today, although that plan hasn't changed. Just woke up this morning and a rainy day. I was supposed to be, with my students, lesson students, white and jump students for next set. We have class today, but due to the rain, we had to make a little adjustment to the time. So within this little moment, I decided to do something for you guys, before I'll be stepping out based on the time adjustment. Now in part 3 of our physics revision, we are going to be giving attention to wave. Now, it's important for you to understand something. When you talk about wave, there are different aspects of wave, because the concept of wave, light, they are interrelated, okay? So you begin with, the definition of wave. You talk about properties or characteristics of wave. And of course, we know some of the characteristics of wave includes the concept of reflection, the concept of refraction, we have interference, we have diffraction, we have polarization. So in this particular live class, quickly we are going to be giving attention to an application of reflection. I had already covered the parts, the theory part upon which the questions we are going to solve in this live class is based. Okay, so I want to believe that if you have been following up with GMAETS 41's classes, then of course you have an idea of what we're about to do now. Meanwhile, in the concept of this wave, don't forget that you also give attention to types of wave, where you study the concept of mechanical wave and electromagnetic wave. All right, mechanical wave requiring a material medium for propagation, while electromagnetic wave, that electromagnetic waves, they do not require they don't require material medium for their propagation. What usually help me, if I want to recall this concept, I quickly think of electromagnetic waves. They do not require medium for propagation. And then we know that we have these electromagnetic spectrum. I use this acronym GXUV IMRI. GXUV IMR. That G is gamma ray, X is X-ray, U ultraviolet ray, V visible ray. Then we have I infrared ray. We have M microwave, and then R we have radio wave. Of course, this name I give to you is very important. Take note. GXUV IMRI. Okay. Can formulate your own, but of course if you are formulating, you must make sure that you arrange this ray, these electromagnetic rays, in order of either increasing wavelength or decreasing wavelength, or increasing frequency or decreasing frequency, as the case might be, because of the formula that frequency is equal to speed of light divided by wavelength. Like this arrangement now is the order of increasing wavelength. So in this direction, wavelength is increasing, which means frequency is decreasing in this direction. Then if you come in this direction, wavelength will be decreasing, which means frequency will be increasing in this direction. So these are all concepts of waves. Are you following? Then when you talk about, once you know these examples of electromagnetic waves, it becomes easy for you to know examples of mechanical wave, because generally, if a wave does not fall in here, all right, if a wave does not belong to any of these components or part of electromagnetic wave, then that wave will be considered mechanical, which means it requires material medium for propagation, but these ones do not. And of course, in the concept of wave, remember we also talk about other classifications of wave to include longitudinal wave and and transverse wave. For transverse wave, the direction of motion is perpendicular to the direction of vibration or propagation of the wave. I take that again, transverse wave. All right, these are waves whose direction is perpendicular to the vibration, to the direction of vibration or direction of propagation of the wave. So if the wave is propagated horizontally, then the vibration is going to be vertical. All right, and also longitudinal wave. Those ones, the direction of motion of the wave is parallel to the vibration, to the direction of propagation of the wave. These concepts are very important. Take note of them, and of course, their examples. Then quickly, we also have terms that we use in describing waves. All right, terms we use in describing waves to include cycle, phase, amplitude. We talk about frequency. We talk about wavelength. We talk about speed. All right, these concepts are very important. They make up an aspect of exam questions that an examiner can likely choose to try you on. And don't forget progressive wave equation, the mathematical equation for no, the network is just network is sometimes wanting to frustrate someone, but like I said, it's just quite unfortunate for network sometimes, because I'll keep pushing to do what I want to do for you guys. All right, let me see, because it seems like the network cut the class off a moment. This is the last thing you're able to hear. Okay. I think when I was explaining the concept of longitudinal and transverse wave, yeah, the network allowed a little. Okay, terms used in describing wave covered also. I'm trying to track where the network interfered from, so that you're trying to see what we can do about network. I want to see where the thing cut off before I can proceed. So when I talked about the progressive wave equation, I think that part of progressive wave equation did not show up. Didn't show up. So I was actually pointing to the fact that after terms used in describing wave, I think I should take the class from there once again. Terms used in describing wave. We have cycle, we have phase, we have amplitude, wavelength, we have frequency, we have speed. All right, these are terms that we use in describing wave. You want to take note of that. So the progressive wave equation, you also want to give attention to that. Progressive wave equation, we have it to be y equal to a sine. I want to write it in the most condensed form, kx minus wt, or could have it as y equal to a sine wt minus kx. Whether the equation is of this form or of this, they are the same thing, it doesn't matter. Observe, this minus does not belong to any one of the two terms. It doesn't. You don't apply this minus whenever you are calculating. That is why that's why the formula can take either this form where the kx comes first, or this form where the wt comes first. Now, take note that our k is equal to 2 pi divided by lambda. We call this the wave number, which means in this equation, you can actually remove this k and fix 2 pi over lambda over wavelength, which if you do that, you get 2 pi x over wavelength. Then again, take note that angular frequency, also known as angular velocity, is equal to 2 pi x, which means one can actually remove this w and fix what? 2 pi f, so that this part of the equation will become 2 pi ft. So you want to take note of that concept of mathematical equation of progressive wave, traveling wave. It's something you want to give attention to too. All right, I think that's it. This particular live class, like I said, is based on calculation on one of the properties of wave. And that property of wave is reflection. Now we have about 5 properties of wave. So we have this question based on reflection, where you study application of reflection, light being reflected by curved mirror. Network is really trying to make a mess of this. It's trying to make a mess of this. The board is a bit cracky, not so clear. It's blurred somehow. Can you see the board from there? Can you see the board from there? Please hold on. Let me see how I boost the network once again, because it seems like please, like I said, remember the condition of the network calls for patience. Okay, calls for patience. I'll keep trying to boost it, as often as possible. Okay, we're going to solve this question directly, but I think I need to attend to somebody here quickly. Lucifer 666 something, I don't know. I remember having warned this nomenclature some time ago, and I think it is high time I kick off this person from this channel. Keep your Luciferous attitude and whatever, wherever you are. This channel is an academic channel, not meant for anybody to come and be posting rubbish here, right? So please give me a moment. I want to see if I can kick him off and be warming up as we solve this question, please. So solve this question. All right, so I want to see. All right, guys, so let's get to business. I just had to hide that nomenclature who comes to type rubbish sometimes on this channel. So back to this, like I said, I had already treated these concepts, the 3 part of reflection and curved mirror. If you have not taken that lesson, make sure you take that in less than 24 hours to your exam. So let us see how you apply that knowledge in solving this question on application of curved mirror when it comes to the study of reflection. An object is placed 12 centimeters from a mirror of radius of curvature 12 cm. Find the magnification and position of the image formed on the same side of the object. When you are given a problem of this kind, the first thing you have to do is to identify the mirror. Is a curved mirror a concave mirror or a convex mirror? Concave mirror is converging, convex mirror is diverging. So you want to identify that. If you look at this question, we're not told whether this mirror is concave or convex. But anytime you have such a problem, there is a particular statement, that would be made to guide you to know what really that mirror is, or which mirror is being considered there. In the case here, I want you to take a look at this part of the statement. Find the magnification and position of the image formed on the same side of the object. Image formed on the same side of the object. In the study of mirror, we have concave and convex mirror, like I said. Concave mirror is that which generally forms an image on the same side as the object, which means the image that is formed by a concave mirror is on the same side as the object. That happens in what I can say 99% of the cases. It's only in one case that the image formed by a concave mirror will not be on the same side as the object. In 99% of the case, the object and the image are on the same side. Convex mirror, the object and the image are never on the same side. So you take note of that. Therefore, based on this statement, image formed on the same side of the object, it simply means that this mirror here is concave mirror. Having said that, we know that this is concave mirror, so we know how to apply the formula. Now, the object is placed 12 centimeters from the mirror, so we have U to be 12 centimeters. We have U to be 12 cm given, and then the radius of curvature R is equal to 12 centimeters. Once you know the radius of curvature, you can determine the focal length. The focal length is going to be 6 centimeters. How do we get the focal length? Focal length is simply, oh my gosh, this thing has started getting blurred again. What is all this? Focal length is simply the radius of curvature divided by 2. I explained that concept in the main class where I taught this. This thing is getting blurred again. It's getting blurred. So hold on. Let's see if I can boost it so that the board will be clearer. It's getting blurred and it's not good. I know you could still see a little, but it's not that clear. Let's see what we can do here, please. Just a little patience. All right. So let us move on. The focal length of a mirror given radius of curvature is simply to divide the radius of curvature by 2. Now, you see this particular question. The magnification can even be obtained without solving anything. In the class where I explained the concept of mirror, I gave the classical interpretation of what you should know depending on the position of the object where the image is going to be formed. And that will help you know what the magnification is. If you see the object is 12 centimeters from the mirror, the radius of curvature is 12 centimeters. Do you see? So the radius of curvature, which is the distance from the center of the sphere that formed the mirror, the distance from that center of the sphere to the pole of the mirror is 12 centimeters. It is that same distance that the object was placed. For mirror, if the object is placed at the center of curvature, the image will be the same size. The image will be the same size as the object. And of course, the image will even be at that same radius, right? At that same center of curvature. I'm just trying to say this, that there are some questions that will be given to you. If you really understand this concept, you don't need to even solve anything. You can answer it directly. If this is the mirror, this is the pole. Now we have, let's say here is the center of curvature, 12 centimeters from the pole. Let's say that this is the radius of, the distance from here to here is the radius of curvature. Let's say this is the principal focus. So from here to here is your focal length 6. Radius of curvature from here to here is 12. So middle of it gives us our principal focus. And the length from here to here is the focal length, which is 6. if I place an object here, which is 12 centimeter, if I place an object at the center of curvature, object O, the image will be formed here as well too. The image will be formed here. But the image is going to be inverted, and the image will be the same size as the object. The image will be the same size as the what? Object. So this is what we understand from the theoretical, application of curved mirror. Which means for this question, even without solving anything, I already know the dimensions of the image formed. The image is going to be 12 centimeter away from the pole. It's going to be 12 centimeter exactly where the object is placed. And the magnification, the image will be the same size as the object. If the image is the same size as the object, it means that the magnification is going to be 1. If you want to learn more about how you can interpret this for certain questions given to you, take that class, that live class on mirror concepts if you have not already done so. So I've already told you that the image V is going to be 12 centimeter. And of course, the magnification is going to be 1 because it's going to be the same size as the object. Let us verify. To verify, we use our mirror formula 1 over F equal to 1 over U plus 1 over V. This is concave lens. This is concave mirror rather. That's converging mirror, which means that the focal length is going to be positive. The focal length will be what? Positive. If it is convex mirror, the focal length will be negative. Take note of that. If I substitute this, I'm going to get 1 over 6 equal to 1 over 12 plus 1 over V, which I don't know. If you clear off this, if you clear off the denominator, the fraction here, using the LCM to multiply out the numerator, the LCM is 12V. Or you can decide to move 1 over 12 to the left-hand side and work out the LCM here and cross-multiply. The choice is yours. Anyone you do, you should arrive at the same answer if you work it correctly. So here I'm going to clear fraction. LCM is 12V, so use 12V to multiply all the numerator while respecting that the denominator will cancel something in the LCM. So 12V times 1, 6 will divide it to be left with 2V. That's going to be equal to 12V times 1. 12 will divide that 12 will be left with V. 12V times 1, V, we cancel that V, be left with what? 12. Now, if you collect like term, this V will move here. 2V minus V will give you V, and that's going to be equal to 12 cm. So the image position away from the pole is 12 centimeter on the same side as the object, right? The image that is formed by a concave mirror is in front of the mirror. It's in front of the mirror. It is only in one case that the image will be behind the mirror. And in that case, the image will be virtual. I explained all these concepts in the class. Are you following, right? Now, what I'm just trying to do is just to solve the question. And before solving this question, I've just opened your eyes to understand that there are certain questions that can be given to you and you don't even need to solve anything. You can interpret it based on the knowledge of what I had already taught and explained clearly in the class where I taught the concept of curved mirrors. Now we have gotten the image position V. You can see it's equal to the object position, 12, 12. What is now the magnification? If the image is 12, the object is 12, magnification is 1, the same size as the object. Is that not so? But just for calculation purpose, magnification is equal to image quantity divided by object quantity. In this case, image size over image position rather, or image distance over object position or object distance. And so our magnification is going to be 12 over 12, which is equal to 1. Of course, you know that 1 is the base value of magnification that separates when the image will be diminished and when the image will be what? Magnified. When you have 1, it means the image is the same size as the object. But if you have less than 1, it means that the image is diminished. If you have greater than 1, it means the image is magnified. The position of this object, since the object, right, is at the center of curvature, because the center of curvature is also 12. The object is at position 12. It means that the image formed will be the same size as the object. If maybe in mirror, like I said, I explained all these concepts. You have the center of curvature here, for example. You have the principal focus here. If you place an object here, that is after the center of curvature, measured away from the pole, measured away from the what? Pole. If the object is here, image will form somewhere around here, and the image will be diminished. If you move the object to the center of curvature, which is this case now, the image will be the same size and will be on that center of curvature. If you move the object further this way, the image will shift backward. The idea is simple. The more the object is moving towards the mirror, the more the image will be moving away from the mirror. So sometimes the object and the image will just cross path like this. Are you getting me? Once it gets to the center of curvature, the next thing, as you move the object towards the mirror, the image will move away from the mirror. I think on that lens, I explained all these concepts, and I kept telling you, friends, that lens analysis is also similar to mirror analysis. A good knowledge of lens will guide you through here. Think, for example, if you bring the object here, if the object gets to the principal focus, the image will now go to infinity. The image formed from the mirror by this curved mirror, in the case of concave mirror, the image will now be at infinity. And whereas if you move the object to exist between the principal focus and the pole, that is less than the focal length, the image of this object will now be formed somewhere here. To be formed somewhere here, that is behind the mirror. And in that case, it's going to be virtual and upright. All the objects placed from here, from the principal focus backward like this, will give you real image, inverted image. They're neither diminished or magnified, as the case might be. I've already opened your eyes to when the guy will be diminished and when it will be magnified. Once object is before center of curvature, the image formed will be magnified. When the image form will be diminished rather, if object is before the center of curvature. If object is at center of curvature, the image will be the same size as the object. If the object is now less than the center of curvature, moving towards the pole, the image will now become magnified. So all that will guide you in the analysis. All right, guys, we have this next question I'd like us to look at. You can write this or screenshot it because I'm going to wipe it right away. Then I'll dictate another question for you. Remember, what we try to do here is what you should know that can help you analyze a question quickly and answer it even without stress in the exam hall. I have this next question we are going to solve. I'll dictate the question if need be, or should I copy it on the board? Let's see how long we have spent. So I don't know what I'm doing. This 30-something minutes already, although network interfered in some cases. So I'm going to wipe this, please. So we look at question number 2. Look at question number 2. For one thing, some of you will definitely, in fact, some of you must see questions, calculation questions on this curved mirror concept and lenses. That one is for sure. You'll see calculation questions from them. So you want to also be prepared. Now I have this next question here. Permit me to copy it on the board quickly. An object is placed 10 centimeter. An object is placed 10 centimeter in front of a concave mirror. Concave mirror is the same as converging mirror of radius of curvature, okay, of focal length rather. What was given here is focal length. They didn't give radius of curvature. If they give you radius of curvature, you know what to do. Divide it by 2 to get focal length. So here they gave the focal length of focal length 15. Of focal length 15 centimeter. I love this question. I love this question because of the placement, the position of the object. All right, what is the position? What is the position and nature of the image formed? And nature of the image formed. Now we have options here. Option A, 30 centimeter and virtual. Option B, 6 centimeter and real. Option C, 6 centimeter and virtual. Option D, 30 centimeter and real. Like I said, if you have good knowledge of this mirror concept, some questions you can make analysis of it. Now, let us see something about this question here. The object is placed 10 centimeter in front of the concave mirror. Now, look at the focal length. The focal length is 15 centimeter, which is the distance from the pole to the principal focus. It's 15. That's the distance. But look at where the object was placed. The object was placed at 10 centimeter. Of course, measured from the pole of the mirror. 10 centimeter is less than 15 centimeter, which means that the object position is between the pole and the principal focus of the mirror. So between, somewhere. I had already explained in that lesson, so recently we even had that class, it was a live class. If this is the focal length, the principal focus, from here to here is going to be 15 cm. That's the distance, 15 cm, focal length. But the object now was placed somewhere here. From here to here of the object is 10 centimeter. This is the only case where concave mirror, converging mirror, will produce a virtual image and erect or upright, which means if the object is standing this way, the image will also stand this way. It will not be inverted like every other position for concave mirror. Once the object is between the principal focus and the pole, simply put, when the object U is less than the focal length, a concave mirror, a converging mirror will now behave somehow like a convex mirror, like a diverging mirror. Because in that case, the image formed will now be behind the mirror. Behind. Not on the same side. The image form will no longer be on the same side as the object. Rather, it will be behind the mirror and it will be magnified, right? It will be what? Magnified. So, that is that. Based on what I've just explained, the options given to us, all we have to now look at is maybe the options that talked about virtual image, because the image formed there is not real. So let us assume that there is only one option that gave us virtual image and all other options gave real. Let's assume. I'll forget about all those other options and go for the one that is virtual. So you can see the idea without bothering myself solving anything. Am I communicating? Like the options provided here, we have option A, 30 centimeter and virtual. So I will be suspecting that. Option B, 6 centimeter and real. That option will be kicked off because the position of this object can't form a real image. Option C, 6 centimeter and virtual. I'll be suspecting that as well too. Option D, 30 centimeter and real. That option D will be kicked. So you see, I'm left with two options to be suspecting. Option A and option C. Option A is 30 centimeter and virtual. Option C is 6 centimeter and virtual. So it's just for you now to calculate the position of the image. It's just for you to calculate the position of what? The image. That's just the thing. We now know that the image is going to be virtual, behind the mirror. So you see, this limits our option to 2, so that the level of confusion will reduce. Let us now do the calculation and see what this is going to be. I've given you the necessary interpretations you need before approaching this question. Because the object position is less than the focal length, it means that the image is going to be virtual. Applying our mirror formula, we have this. Concave mirror F is always solved using positive sign. If it is convex mirror, you see this F, if they give you the value and you are fixing it, you're going to include negative sign. And take note that here I did not divide anything by 2. I didn't, because we were not given radius of curvature. to now get focal length by dividing radius of curvature by 2. Nothing like that here. We have the focal length directly. So let's substitute. 1 over 15 is going to be 1 over u. Our object is 10 cm, and then the image we don't know. So work on this. Okay, this time around, let us move this 1 over 10 to the left-hand side and do the LCM. So if 1 over 10 moves here, it becomes minus. Follow through as we apply the network of our brain to quickly analyze that without wasting time. Of course, you always have to be training the network of your brain. Very important. If 1 over 10 crosses, we'll have 1 over 15 minus 1 over 10, right? So the LCM of 15 and 10 is what? 30. So if the LCM of 15 and 10 is 30, you come here, use 30 to multiply this one. 15 will reduce it, so you have 2. Equal to, use 30 to multiply this one. 10 will reduce it, you have what? 3. So 2 minus 3 will give you minus 1. Which means that here we are going to have minus 1 over 30 equal to 1 over v. Remember, 1 over 10 has already moved. So you have 1 over v here. At this point, this is 1 over, just inverse. Move denominator up and numerator down. So you have 30 over 1, v over 1, which is same as 30 and v. But here is minus. Therefore, v is equal to minus 30 centimeter. Why did we get negative result here? The negative result simply tells us that the image is virtual, not real. And with this calculation, the correct option is option A, 30 centimeter and virtual. So we are done with this. We are done with this. You see the position of this object here. The position of this object here makes this concave mirror to behave 99% the same way convex mirror behaves. Because this image is going to be magnified, right? This image is virtual rather, and it is erect. In fact, let me indicate it. Virtual and erect. Because of the position of this object for concave mirror. Convex mirror generally form virtual and erect or upright image, whatever the position of the object is. Convex mirror will always form virtual and erect or upright, as you might call it. But concave mirror only forms this under one case, one condition, when the object position is less than the focal length. So all these concepts, please have it here, very important. I've told you the implication of this negative sign. The only difference between concave mirror in this position of object and convex mirror is that the image formed will be magnified here. The image formed will be what? Magnified. In fact, let me indicate it. Magnified. You can verify that by solving for the magnification v over u. V is 30. U is 10. 30 over 10 will give you 3. 3 is greater than 1, so it is magnified. If it were to be convex mirror always produce diminished image smaller than the object. That's just the difference between convex mirror and concave mirror for the position of this object here when dealing with concave mirror. Why concave mirror under this condition will produce magnified image, convex will produce diminished. So please remember this concept. Remember this concept. We are done with this, and I think we've got the next question to deal with. Let's look at this question. There is a little calculation question I'll release later. I'll even dictate the question for you guys. The magnification of the image of an object placed in front of a convex mirror is 1 over 3. The magnification of the image of an object placed in front of a convex mirror is 1 over 3. That's the magnification. If the radius of curvature of the mirror is 24 cm, if radius of curvature is 24 cm, what is the distance between the object and its image? I won't solve this question now. I'll release a pre-recorded video on it, but I'll just tell you the analysis, right? Just feel like I want to release a pre-recorded video. It's a tricky question somehow, but I don't want to do it live. I have this other question I want us to solve. It's no longer a calculation, the next one. But let me give you the analysis of this question. Say we're given the magnification. Magnification is 1 over 3. If magnification n is 1 over 3, I know that 1 over 3 will now be equal to v over u. So simply our v will now be 3 divided by, right? Our v is going to be u divided by 3. V will be what? U divided by 3. Simple. Look at what I'm talking about. Magnification is 1 over 3. You know that magnification is v over u. So 3v will now give you u, and v will now be equal to u divided by 3. Anytime you are giving magnification, the reason for that is for you to be able to get the image position in terms of the object. That's the main reason why that is usually given. So first, in this question, you have to get v, right? And v is u over 3, like I showed you. So you're going to see something like that when I upload the video. It's going to come up today live, right? It's not live anyway, but I'm going to upload it today. That's what I'm talking about. Does that make sense? So now that you've known your image position, which is u over what? 3. In the question here, they gave us radius of curvature, right? Radius of curvature of the mirror is 24 centimeter. As usual, get your focal length from there, which is 24 over 2. You get 12 cm. So the focal length is 12 centimeter. We are asked to find the distance between the object and the image. So you can see the trick in the question there. That is where the trick comes in. You are not just asked. The question did not just ask you to find the object position. We know the image position already. It is u over 3. Now, we were not asked to find the object position just like that. The examiner says you should find the distance between the object and the image. So try to understand a question when you are being exposed to it. If this is the object and this is the image, you are asked to find the distance between them, which simply means all I have to do is know the image position, know the object position, then subtract, do a subtraction. The bigger one minus the smaller one. So you see, this question is simple. The first thing you have to do is to calculate your u. If you calculate your u, fix it here and get v. Of course, you are going to use 1 over 12. This 12 is going to be minus because it is convex lens. The question says it is, sorry, convex mirror rather. The question says it is convex mirror. So 1 over f will be 1 over 12 minus 12 equal to 1 over the image position v is u over 3. Then plus 1 over u. This is 1 over v, where v is u over 3. Then plus 1 over u. Then from here, solve and get your u. Of course, you know that this 3 will go up. If 3 goes up, find the LCM. If you work on the LCM, what is that? This common denominator, u here. So if you solve out this part, get your u. Once you know the value of u, substitute it here in this v equal to u over 3 to get the value of v also. Once you know the value of v, you have already calculated the value of u from here. Do the subtraction and you get the answer there. Let me dictate the options for you anyway. I've already read out the question, so you can replay the video at the end of this live class. You can replay to still get the question. You can solve on your own while you wait for the pre-recorded video. Option A is 8 centimeter. Option B is 16 centimeter. Option C, 24 centimeter. Option D, 32 centimeter. So solve it and see if you can get any of the option while you wait for the pre-recorded video to be uploaded before the end of the day. All right, listen to this question, please. Just listen. It's not calculation because that's the last thing I want to do as we close this live class. And I hope the network is ticking. All right, someone had dropped this. Okay, 32 centimeter. That's what the person dropped. That's good. Sikham. Sorry, I apologize. I am back too. So why are you apologizing? I don't know if you did anything anyway, but you're welcome. And you have dropped the answer to be 32 centimeter. That's good. I don't know yet because I am here to solve it. All right, but I've given you the breakdown. So if you follow through, then calculating and you get 32 without making any human error in the calculation process, then we assume that you got the answer, right? But I don't just want to do anything about solving it here. Just attempt. Now, listen to this question, please. Listen and listen very good. A pencil is placed vertically between a concave mirror and its focal point. I repeat. A pencil is placed vertically between a concave mirror and its focal point. Focal point, principal focus. So a pencil is placed between the concave mirror and the focal point and the principal focus. Are you following, right? The image of the pencil in the mirror will be, the image of the pencil in the mirror will be A, real, inverted, and diminished. Option A is wrong. The image cannot be real in this case. This question given here is not calculation. It's not. But it follows this principle. Because this particular question you see here, which we calculated to get minus 30 centimeter, the object is placed between the mirror and the focal point. You know, talking about the focal length, it is the length from the mirror to the principal focus, also called the focal point, according to this question we're analyzing, which was 15 there. Now the object was placed between, in this case, 10 cm. And you remember what we analyzed about this question. So the same thing will apply to this particular question. So you listen to the option. Option A said it is real. And of course, from what you've learned here, there is no way under that arrangement, there is no way the image will be real. So option A is off already. B, virtual, okay. Inverted and enlarged. That inverted spoils everything. Option B said virtual, inverted, and enlarged. Because of that inverted, that option is wrong. Because like I explained here, under that condition, that arrangement for the pencil to be placed between the mirror and the focal point means that the object position is less than the focal length. And there is no way in that position, there's no way the concave mirror will produce an inverted image. I guess you get what the answer should now be, right? Since we have, you know, taken off option A, we've taken off option B, and you observed or you listened to the explanation I gave. So that should now give you a classical idea of what the correct answer should be. Let us look at option C. Option C said real. Should I still go on now? It's not real. I've said that already. So option C, starting with real, means that option is off. But let me read it out again. Real, erect, and enlarged. That real spoils everything. Enlarged, yes. Okay, erect, yes. But the real cancels option C. Finally, listen to option D. Virtual, erect, and enlarged. Enlarged means magnified. Does that not define what we have here? Virtual, erect, magnified. And I told you that it is only under this condition of or position of object with respect to the focal length that a concave mirror can form virtual, erect, and magnified image. And of course, that is what option D said here, virtual, erect, and enlarged. And that brings us to the end of this morning live class. Remember, this is as good as we have treated part 3A. Yeah, I have revised part 3A of wave for you guys. I'll be going to work now. I need to attend to our JAM and YX students for next set. You can feel what the GMAT 41 is doing. We are out to help students. We are not out here just in the name of exam. No, you need to learn beforehand. Start early and prepare. So I'm using this opportunity to inform you guys in case of anyone that wishes, okay, let's not say wishes to rewrite, because any one of you that rewrote JAM could have happened this particular year's JAM. So if you know of anyone, your friend, your brother, your neighbor, your relation who is sitting for WAEC or JAM or NECO for next year or external GC for next year, the person is in Awka, Anambra State, direct the person to GMAT 41 at our office or center at IDK, right? And if you're not anywhere near Awka, but you still love the GMAT 41 to work, remember we have rock solid full online classes to prepare you. You can join us as well to contact GMAT 41 to get registered. Today, at our venue, we're going to be dealing with English and biology anyway. I'll be seeing you later this evening. But before then, remember that I've already arranged physics 102 revision playlist for you guys, divided into 3 parts. Part 1 and part 2, we have covered them, which is electricity and magnetic field. Yesterday night, we treated magnetic field, right? And today, I've introduced wave. We hope later, I'm going to give a summary of the things you also need to focus on the remaining part of wave. Make use of the playlist. If you're not a channel member yet, what stops you? You can do that today. Join the platinum or the diamond level. Support GMAETS 41. Get access to these revision videos where you see a lot of things. Remember, what I'm doing here is just to summarize some things for you. Like I told you, this time is no time for much stress like I did last semester. So make use of the playlist, become a channel member, and then you access them all. Like I said, I'll be seeing you later the evening. Share the link to this live class to your friends, to your departmental WhatsApp group. Encourage them to link up and learn so as to prepare for their examination. And of course, as always, the GMAETS 41 continues to wish you all the best. If you've been following all the things that GMAETS 41 has been doing for you, if you've been taking your studies seriously accordingly, you will go in there tomorrow for our dear Unizik students, and you are going to get us that A splashes, first class in view, which you deserve. Nothing can stop that. Except otherwise, you decide to stop yourself. From this platform, as much as 98% of your exam questions are already covered on this platform. Yes, I say that with 100% confidence. You are going to state the testimony when you are done. Of course, it's not the first time, it's not the second time. It is a recurring decimal from this platform. You go in there, everything we cover on this channel, you are going to see questions just right from there, which means the answers to your exam questions are right there with you in the comfort of your home. The question now is, are you ready to grasp the opportunity? Become a channel member, access all the video lessons, and go in there to ace your exam. Don't forget, finally, I've always told you, if you have that textbook of yours for those in Unizik, make sure you cover all this, solve the examples there. Then all those key points where they define some things, this is physics anyway, senior brother in science. Yes, senior brother in science, because here you talk about definition of terms, laws, properties and characteristics, key notes on certain concepts, and then calculation part. That is why the way you approach revision in physics is not as the same as other courses. In maths, it's simpler. In chemistry, it's a bit easier. Physics, no. So follow through the way I have divided this revision into 3 parts. You're sure of your A in this course. Have a wonderful day. See you later.